Hi everyone, this video is an exercise 14H question 8. So we have a modeling question in which a scientist is modeling the number of people n who have fallen sick with the virus after t days. And we are given this line with 2 points, so points 0, 1.6 and 10, 2.55. Now, the scientist suggests that the number of sick people can be modeled by this exponential equation where a and b are constants to be found, and also the graph passes through the points. So we want to write down the equation of the line in part A, which is a GCSE question. So we just first find the gradient. So the gradient is equal to y2 minus y1 over x2 minus x1. And so we just substitute, right? We have 2.55 minus 1.6 over 10 minus 0. And the gradient is 0.095. So we also have the y-intercept, so we don't need to use the full formula of finding the equation of the line. So we can immediately write y is equal to 0.095x plus 1.66. 1.6 is the value of y-intercept. Well, just one thing to be careful, out of habit I wrote y, but remember that the y-axis we have log n, which relates to this topic. And then here we have x, sorry, we have t, not x. So just out of habit of the usual, y is equal to mx plus c. Right, so now in part B, we want to use this equation to find the values of a and b. Right, so to find the values of a and b, we can basically use the idea that n is equal to ab to the power of t, and we need to take log so that we have this in the form of this equation in part A. So if we take logs, we'll have log a is equal to log ab to the power of t, but remember that log loss allows us to split this into the sum of two logs, so we can write this as log a plus log b to the power of t, and also the power law allows us to write this power of the number inside log outside of the log as a coefficient. So this becomes log n is equal to log a plus t log b. Okay, now remember that from part A we also got the equation log n is equal to 0 point, actually let's rewrite this as in for 1.6 plus 0.095t. To solve this, we equate the coefficients. So remember that this 1.6, which is the y-intercept, is equal to log a. And now remember that the base of log in general is 10. So in this case, we'll have a is equal to 10 to the power of 1.6. And this is approximately equal to 39.81. Now just repeat the same thing for the next part, because remember that log b has to be equal to 0.095, because both of them, basically this is that mx term basically in the usual linear equation. So just similarly, we'll have b is equal to 10 to the power of 0.095, and this is approximately equal to 1.24 to two significant figures. Sorry, to two decimal places. Now, in terms of the answer, we want to give the answers to the two significant figures. So for the value of a is actually equal to 40 to two significant figures, and then b is equal to 1.2. So now we have a and b. So in part C, we want to interpret the meaning of the constant a in this model. So that's interesting because the model is basically n is equal to ab to the power of t. Now when t is equal to 0, then we'll have n is equal to ab to the power of 0, which means that n is equal to just a. And this should remind you that this is the basic y-intercept that we have, and normally in questions y-intercept just means that the initial number of that quantity. So in this case, a is simply the initial number of people who were sick, so at day 0 basically. So that's the meaning of n. So the a means the is the initial number of sick people. Sick people at day 0. It's very common. In part, use your model to predict the number of sick people after 30 days and then give one reason that why this might be an overestimate. Okay, so for prediction, all we need to do is that we just need to substitute 30 into this equation, and remember that we have already found A and B. So because we found that B is 1.2 and A is equal to 40, so we have N is equal to 40 times 1.2. Or actually, one thing that I think is more helpful maybe is to rewrite the equation as exact value, so in the form of exact value. So because for A, the exact value is 10 to the power of 1.6 times, and then B is 10 to the power of 0.095. And then remember that outside, so we have AB to the power of T. So here it should be clear. So that just means that if you want to predict after 30 days, remember T is just the number of days. So you just write 30 outside. And now we have N is equal to 28,183.8. However, the question says that well, since the previous numbers the previous part was to two significant figures, but here it's not stated to how many significant figures, so we can just write this as basically around this and just write like this in this case. Yeah, so now the reason that this can be an overestimate, that's just because this model N is equal to AB to the power of T assumes that there is an exponential growth, which means that the virus, just the number of infected people keeps increasing exponentially, which is unrealistic because at some point it's just going to stop, or at least the rate is going to significantly decrease. So that's probably the main limitation of this model, because it assumes that we have an exponential increase forever, basically, which is probably going to be an overestimate.